So in this video we're going to go over just the basics, the intro of a heat exchanger, and how to understand the symbol for the heat exchanger. So what a heat exchanger does, it's in the name. It exchanges heat, okay? Think of like your vehicle, for example. You know you have oil in your vehicle, right? And you also have a cooling system, cooling water, and that's what you put your antifreeze in your vehicle. So the cooling water is going to cool off the oil, right? You don't ever want to get water in your oil, do you though? Right? Am I right? And what the heat exchanger does, and its purpose is to exchange heat. It's either going to be cooling something off or heating something up while preventing the two fluids from mixing. What I mean by fluid, I know most of you correlate fluid with the liquid. I used to too. That's not abnormal. But a fluid is actually anything that flows. So smoke from a fire could be considered a fluid. So it could be any form of a gas, aka vapor, or any form of a liquid, right? It's not going to be a solid. So this is a shell and tube heat exchanger. There are multiple different types. This one happens to be a U-tube. I don't know why they don't call it a C-tube, because usually they're horizontal like this and not like this, but that's above my pay grade. So your tubes are these orange things. Your shell is this big clear casing around them. You'll have one fluid going through your shell side and one fluid going through your tubes, okay? I'm gonna go ahead and zoom in and show y'all the tubes. So do you see how they're hollow? And what I mean by that is, oh, sorry, they have little holes on the inside of them, right? Based on that zoomed in view I showed you a while ago, to where your tubes are hollowed out, to show you that your tubes are hollowed out and you can have flow going through them. Sets of inlet and outlet, okay? You're gonna have your shell side inlet and outlet and your tube side inlet and outlet. So here's one set. I don't know if the camera can see. Here, right? And then here, okay? So based on that, which set do you think would be for your tube side? So with whatever students end up saying this, I would ask, how was it going to get inside of your tubes from here or from here, right? It can't. That's going to be for your shell side. And the way thing right here, this is your pass divider. So your tubes, let's say this is the inlet. It can be either way. This could be the inlet and this could be the outlet, or this could be the inlet and that could be the outlet down there. But we're just going to go with this is the inlet, okay? So it's going to come in. This pass divider is going to prevent it from going to the bottom. And it's going to go through the hollow tubes, go all the way around, right? All the way around. And then it's going to come out down here, or vice versa. And your shell, if your tubes are coming in at the top, you want that counter current flow. So if that's the case, your inlet would be here. It's going to go, well, I forget, y'all can't see me on that side, like this, and then come out. Based on what we just looked at with our little clear shell and tube heat exchanger, which of these, I'll try to do the other one with a different color, right? This is going in, and then I'll do a different color, that way y'all can kind of see it. Let me find a pen. Let's see if this one works. Do y'all think the pencil or the pen, let me see. Do y'all think the pencil or the pen would be the tubes? So the tubes are going to be the little squiggly lines, right? Inside of the shell's going to be the circle. So this would be your shell inlet and shell outlet. This would be your tube inlet, tubes inside the shell, tube outlet, right? A common mistake I see my intro students make is they'll have their arrows both going in on the tubes or both going out on the shell. So you have to have flow. If flow is entering the tubes, there has to be flow leaving, right? You don't want both arrows going out like this right? That would be wrong. And you don't want both arrows going in. That would be wrong, right? Okay, and then, so always make sure you have a flow going in your tubes and out your tubes, and then in your shell and out your shell.